Welcome. In this lecture, not only are we going to talk about what it means for a function to be surjective, but also how to prove that a function is surjective, something that one is often asked to do, in fact. So here we go. So here's the definition. So we're going to say that f is surjective. So f is surjective. Okay. And another name for surjective, and so it's good to know this, is or onto. So these mean the same thing. Okay, so I also wanted to box this. So what does it mean to say that f is surjective or onto? It means that, so for each, I didn't establish for you yet that, so f is going to be a function that's going to run from s to t. So s to t is a function. And then we say that f is surjective if for each, and then we have for each t in our codomain t, there exists, just to remind you, this symbol means there exists. Okay, so there exists an S and S, so that we have that if we take f of s, we're going to get out t. So if I take f and I input my s, then I'm going to get out my t. Okay, so the picture is that I have s over here, and I have t over here, and I have my function f, and I have some lonely t. So maybe, in fact, and let's maybe give kind of, let's say that there are only two elements in here, and maybe this in some sense is a good example, actually, because for finite sets it does actually kind of work like this, that, you know, so maybe this one is going to go here, and this one is going to go here, and then this is a not surjective picture, so this is the no picture, because, right, so this was a no picture because this was a not surjective picture because we had some t, you know, that nothing mapped to. Okay, so because there was a lonely t that nothing mapped to. There was a lonely t, nothing mapped to. Okay. In other words, we're going to have that in order for f to be surjective, so in order for f to be surjective, it must hit every value in t. So every value in t. So it must hit every value in t. Okay. So this is what this means. Now another, so in other words, and yet another interpretation, right? It's good to have lots of interpretations. So what else is this telling me? So another way to identify this is that f of the, the image of the entire set is going to equal T, i.e. the codomain equals a range, i.e. the codomain equals a range. So i.e. the codomain equals a range. Okay, so that's another kind of important interpretation that sometimes you'll use. But here we go. So how do we prove? And I think this is important to know how to do. So how do we prove surjectivity? And just to be clear, this is a for all there exist proof. So this is a for all there exists proof. It's kind of a standard form. Right? So the first thing I want to do is I want to let T and T be arbitrary. Right? And then so find in your scratch work and S and S such that when I apply F to this, I get T, okay? And then you do need to actually show, right? So the part that you actually include is you do need to show it works, right? What does that mean? That means show that F of S equals T. Okay, so let's talk about this a little bit. So surjectivity means I hit everything in my codomain. There's nothing that's left untouched. So my codomain is the same thing as my range. Proving it, this is a for all there exists proof. So you need to show that for an arbitrary element in here that there exists some S in here that hits it. That's one way to show. Sometimes also you might actually, so this is to prove surjectivity. This is like a one way to prove it. There are other times actually, at times you actually use a proof by contradiction. Suppose that everything is hit, and you can reach a contradiction. So when I'm giving the way to prove it, this is like the most common way to prove it. In most circumstances, this is what you're going to want to do. But there may be circumstances where you want to use something else, such as a proof by contradiction. Suppose for the sake of contradiction that the codomain equaled the range, and then, oh wait, I have a problem. Okay, so I hope that was helpful, and I will see you in the next lecture.